So now let's discuss the answers to how to figure out, when given two alcohols, which one is going to react more quickly when reacted with HBr. So remember that we are reacting each of these with HBr. So the halogen is not going to have any effect because it's the same for all the alcohols. So what we're really using to determine which of these is going to be faster is the degree of substitution. Remember earlier we said tertiary is faster than secondary, faster than primary, and faster than methyl. So we first have to draw each of these. So 1-butanol has 4 carbons and an alcohol group on carbon 1. 2-butanol has 4 carbons and the alcohol group on carbon 2. If we look and focus on the carbonyl carbon, we can see that 1-butanol is primary because the carbonyl carbon only is attached to one other carbon, and 2-butanol is secondary because the carbonyl carbon is attached to 2 other carbons. So secondary wins. 2-butanol is going to react with HBr faster. To draw 2-methyl-1-butanol, we just draw 1-butanol again, and on carbon 2 we need a methyl group. And the other alcohol is just 2-butanol again. So we already know 2-butanol is secondary. If we look at 2-methyl-1-butanol, it's still primary. The carbonyl carbon is still attached to only one other carbon. So 2-butanol wins again. In letter C, we're going to draw a cyclic alcohol. So we're going to start with our cyclopentane ring. If it doesn't say a number here, assume that the alcohol is attached at carbon 1. There's a methyl also attached at carbon 1, so we have a methyl coming off of here as well. Cyclohexanol is just a 6-membered ring with an alcohol group attached to the ring. Looking at our carbonyl carbons, we can see that the carbon for 1-methyl cyclopentanol is attached to 3 other carbons. It's tertiary. And the carbonyl carbon in cyclohexanol is only attached to 2 other carbons. It is secondary, so the tertiary is faster. In the last one, we're going to redraw methyl cyclopentanol again. We know that one's tertiary already. And our other alcohol, this time, is another cyclopentanol, so another cyclopentane with an alcohol. We're going to automatically make that carbon 1 because it doesn't say in front of the cyclopent. And this time the methyl group is on carbon 2. It says they're trans, so that means that one of them is going to be facing you and the other one is going to be facing away from you. That's really inconsequential for this problem. All we care about is the carbonyl carbon and how many carbons it's attached to, which is 2. It's secondary, so our winner in this case is 1-methyl cyclopentanol.